Good evening to one and all. Is the audio and video clear to all? Is my voice audible to everyone? Thank you. So let us begin our today's session on abstract algebra. So this is a orientation class for everyone. So you can ask what are the doubts you have with regard to the preparation, syllabus and everything. So please take your choice and ask your questions right now. Then we will start our class session. Okay, you please go ahead. So whatever the doubts you have, you can ask right now. Sure. I will give the complete syllabus. I will give the books, what you have to prepare for yourself. And I will give the preparation model. And the time also, how much time it is required for you for the completion of syllabus. So any other questions for anybody? And I will tell one more thing. What are the advantages and disadvantages for this particular topic? Any queries for anybody? Say. All right. So if you have any other doubts apart from these things, you can ask. Any other doubts for anybody? All right. Then, first of all, let me read the syllabus first. So please take a note of the syllabus. The syllabus part, if you consider, so the total syllabus is bifurcated into two parts. This is part 1. Then we go with part 2. It is given as rings, subrings, ideals, homomorphism of rings, integral domains, principal ideal domain, Euclidean domain, unique factorization domain. And you have other fields, that fields and quotient fields. So this is the total syllabus with regard to abstract algebra. You first take a note of them, then we discuss what are the areas we need to concentrate in the whole syllabi. Once you have taken a note of that, then please tell. Yeah. So have you taken a note of the syllabus, all of you? Right. Then it will take minimum 50 hours to finish the total syllabus. So as per your interest is concerned and your learning time, we can increase that. The total hours required to finish the whole syllabus in detail. Okay? Right. So can I erase this syllabus part? Fine. So in the total syllabus, the areas we need to concentrate is isomorphism theorems, normal subgroups, and here integral domains, PID, Euclidean domains. So actually what happens, if we take a close look at the previous year question papers, majority of the questions were asked from these parts: principal ideal domain, Euclidean domain, unique factorization domain, and integral domain. Later on, problems were shifted to the part of isomorphism theorems, normal subgroups, and cyclic groups also. So the total syllabus will be simply taken into consideration as groups and rings. You can call it as group theory and ring theory. This whole part we call it as group theory. This whole part we call it as ring theory. So these two are the part of abstract algebra. So earlier more weightage is given to the second part because the second part is the extension of the first part, and nowadays priority is given to the first part equally also. There is the whole thing with regard to syllabus and what areas we need to concentrate more. Okay? Since each chapter has the equal weightage, the minimum weightage is nothing but 50 marks, 50. The advantage is part 1, part 2 are not totally interconnected. So this is a separate system, this is a separate system. So if you concentrate on the first part, then you are able to get at least 20 marks with regard to exam point of view. Similarly, if you concentrate only on second part, the minimum weightage guaranteed is 20 marks. Okay. Any other queries for anybody? Please tell. Right? Then I will erase the syllabus part. We discuss the other things also here. I will give each and everything. So what are the merits and demerits? The merits for this part is there is no need to learn any prerequisites because this is totally a new chapter with regard to your core subject. Either you belong to the BTech or something else, it is totally different. So there is no need of having any prerequisites with regard to the content. Other, you will get the repetition of questions. Third one is, if you talk about the material level, how much material we need to prepare or concentrate, it is small amount of material, not huge. In other words, the class sessions are sufficient for you. With regard to the exam point of view, class sessions are sufficient. There is no need to study more number of books. No need to study more books. So, coming for the disadvantages or demerits you call, the thing is, here it is the logical orientation. And we have certain theorems. So we prove the problems based on theorems. That's it. This is the only demerit we can think about. Because if you take calculus, complex analysis, linear programming, or numerical methods, or vector calculus, initially the logic is very small. Then, based on the logic, we will have a certain formula. Substituting suitable values in the formula, we will evaluate the whole problem, isn't it? But here, the thing is, as and when you start a concept, let me say groups, then the first chapter contains initially some definitions. Or you can take it as concepts. So, once you understand the concept at the fundamental level clearly, then you are able to solve the problem. If you didn't get the definitions completely, then problem solving is very difficult for you. It is just like a nightmare for you. Okay?
Hello.
So these are the merits you can call upon, these are the demerits you can call upon. And the best advantage of this syllabus, I want to say, is no separate exclusive preparation. So I will say one thing, that suppose you are studying the part of calculus. So once you finish it with the syllabus, again you go for the revision, there you need to practice certain kind of problems for good reference, isn't it? Say, but for here, once you understand the concepts at the fundamental level clearly, so whatever the problem asked, it is purely based on the definition and concept. You are going to solve it logically on the paper itself. So the revision preparation is very minimum with regard to the abstract algebra part. That you please take a note of that. But if you take the case of complex analysis, vector calculus, anything, you need to go for a good time of revision. But here the revision time is very less. If you study at the class level very correctly earlier, that is the advantage of it. Okay. It has many applications with regard to real life, many applications in chemistry and other fields also, where this type of technique is applicable. Now, I am going to list out the books which you need to study for your study time. The list of books you need to study. So there are many books available. Among that, you can pick up one book for your side. You can take Modern Algebra by Krishna series, or you can call it as Abstract Algebra also. So Abstract Algebra by Sham series. Basic Abstract Algebra by V.K. Khanna, S.K. Bhambre. Abstract Algebra by Joseph A. Gallian. Abstract Algebra by S. Chand Publications. So these are set of books available for you for your study. You can pick up any one of them, not all. One book is sufficient for you. So if it is possible for you, you can take a book that Basic Abstract Algebra by V.K. Khanna and S.K. Bhambre. Right? And with regard to Sham series, the whole syllabus is bifurcated into two parts. For group 3, one Sham series is available, and for ring theory, another book is there. So while purchasing a book through online, you take a note of the syllabus. What are the contents in that book? Then you can purchase that. Okay? Yes? See, every book we are learning for the sake of fundamentals only. Please understand. For the sake of fundamentals only we are studying. Because it contains only the logical approach of the problems, not more number of problems. Generally, if you take any multivariable calculus or complex analysis, anything, there you need to solve a lot of problems after your preparation. Here, there is no need to solve problems. You have limited number of questions. If you learn them thoroughly, those questions will be given exactly in the exam. So majority of them are nothing but the worked out examples in the textbook. That is the advantage of this part, abstract algebra. And let me one more thing. While attending the class sessions, you should be ensured that you have understood the concepts and fundamentals of the previous classes, because tomorrow we have done some part of group theory now. So for next session, we have to take care of the previous class concepts into your mind. Otherwise, you cannot get into the pipeline to understand the current topic that you need to correlate for every time. So the basic definitions and the theorem statements, what you are using, the results, it should be memorized for you prior to the class session. Then it is just like a cakewalk in solving everything. The advantage is we have limited questions for preparation, not more. That is one good advantage. The only disadvantage is with the logic. If you fail to get the logic in the first place, then you cannot go for the other questions. You just feel like it is a very great dry subject. Why you are doing all these things? Because it is totally a different thing compared to the regular math. All right. So if you are clear with this part, there are many other books also there. Abstract Algebra by P.B. Bhattacharya. That also you can take. So what are the book you are going to study? You are just learning for the sake of concepts and good number of examples. That's all. Not more than that. Now I will erase this part. So if you are clear with your all doubts, let us start our class session now. May I? Or you want to add something? And while the coverage of syllabus, as and when assignment is required, I will give the assignment separately. Otherwise, there is no need to do any assignment. Class sessions are sufficient for you for the whole preparation of the syllabus. Right. So let us start with the concept of groups. Now, let us consider the number system first. So we have the natural numbers, whole numbers, integers, rational numbers, real numbers, and the complex numbers. This is our number system. And we have certain arithmetical operations with us: addition, subtraction, multiplication, and division. So among these sets, you pick up a number system. Let me say I have taken the natural numbers where they starts from 1, 2, and so on. Now, among these operations, you pick up one operation. Let me say plus. So what I am saying is, if you take any natural numbers, any two values, if you do addition, is the result again a natural number or not? Say yes or no. I will take any two natural numbers in this set. I am adding them. Is the result again a natural number or not? Yes. So if you have a doubt, I take a natural number A, a natural number B, I am adding them. Is it belong to n or not? That is my question. Did you get it now? All of you? Right. So Since it is a natural number, we say that the operation plus is closed on n. In other words, we can say that the natural number set and plus have closure law. So while getting the definition of group, we have to go some fundamentals and some concepts. Then I go to the definition of a group. So what is meant by a closure law? Whenever a set is with you and you got an operation with you, you are applying the operation on elements of the whole set. If it satisfies, we say that it is closure law. What is meant by satisfies? It is just if you perform the operation on the elements of that set, the result should belong to the same set again. That's it. So for our good understanding, I take the operation minus. Now let us check n comma minus. So is this operation closed on n or not? It means that if I take any two natural numbers, if I subtract them, is it again a natural number or not? Can you tell? All of you. I have taken two numbers. They are natural numbers, starting from 1, 2, so on. Any two numbers you can take. I have subtracted them. Right? So it may be, it may not be. For example, my condition is I take two numbers A and B. I am performing A minus B. My question is whether it belongs to n or not. So if you take A is 3 and B is 2, the result belongs to n. If you take A is 3 and B is 4, it does not belong to n. It is some other number. Agreed? So what happens? The first operation satisfies closure law. The second operation minus is not closed because there are certain numbers which violate this condition. So minus is not an operation which is closed on the natural number system. Now, did you get the concept? What is meant by closure law? Fine. So, with regard to group theory, we study the concepts using two operations for the whole time. One operation is addition, another operation is multiplication. So we are not doing problems on division and subtraction. So we are verifying the properties with regard to addition and multiplication only. Now let us look into the other properties. We have discussed one property, that is closure law. Now I am giving another definition, that is associative law. Yes, we have other operations and also groups in general. First, I have finished with the properties, then I will tell you the whole theory of that. Apart from plus and into also, I will tell. Okay? So give me a time, I will finish your part. So associative law means, let me say, I have taken a set S where plus is the operation, addition is the operation. Now you take any three elements in the set. Now I am verifying that so you perform the thing B plus C, and then A plus. First you perform A plus, then plus C. So are they equal or not? We will verify. So you can calculate the LHS, you can calculate the RHS. So if they both equal, we say that it is associative law. So plus satisfies associative law on the set S. Then I will give the other property, identity. Again, you take the set S, I take the operation plus. Now the question is, if I take an element A belongs to S, I need to calculate a value such that after adding, I should get A again. So if you take the whole numbers, W, if you take any number, say 5, on adding what value you will get 5 again? 0. So is 0 a part of W or not? The whole number system. As we have natural numbers, whole numbers, integers, etc., etc. So we say that the set W has identity with respect to the operation plus. If you think about the natural number system, since 0, the number 0 is not there, n has no identity. Only W has identity because the set starts from 0. So if a set contains identity element, we denote the element with the symbol E. So E stands for identity in that set. If you are clear with this property, then I take the next one. Shall I? Fine. Now the other thing is, if you take an element A, we will check that is there any element in S such that if you perform the operation, you should get identity. You can perform the operation either of the way. You can do A plus something or something plus A. For example, if you want to talk of numbers, let me say I have taken 5. On adding what value, I will get the identity 0. Minus 5. So we say that minus 5 is inverse of 5. So if you talk of general terms, if I take an element A belongs to S, I should find another element B which is in S such that on performing the operation, I should get identity. So this is called inverse property. Now, the formal definition of group is defined by whenever you take a set S, you have an operation with you. This operation, technically we call it as binary operation. We call it as binary operation or binary composition. So whenever you have a set S with some operation, say plus, it must satisfy all the 4 properties: closure, associative, identity, and inverse. If these 4 properties are satisfied by a set, particularly with one operation, we call it as a group. That is the definition of a group. Okay. Now, if you understood the concept of group, as we have considered the number system, let us think that in the number system, what are the groups? So I have natural numbers, whole numbers, integers, rational numbers, real numbers, and complex numbers. So where associative law is violated, generally associative law will not get violated. As in when closure is satisfied, associative law will definitely be satisfied. So if the thing is, if you take negative operation on the set, where associative law will be violated. There is the example I am going to give. Right? Suppose let me say you take the integer set. Now, if you take minus, it is a closure operation on Z, because you take any two numbers, you subtract them, the result is again integer. It may be positive or negative, whatever may be, it again belongs to Z. So if you take any three numbers, A, B, C, you cannot give guarantee that this always holds. So associative law will be violated on the set Z if you use the operation minus. Okay? You can take with the numbers, say you take 3, 4, 5 and check whether you got the same idea or not. You can verify, you calculate LHS and RHS separately, or they become equal or not. That should be true for every three numbers you have taken in the set Z. Clear? Right. So, since we are not considering the operations minus and division, our interest is to do the things for plus and multiplication only. So, we are not taking the case of violations, we are taking the case of optimistic way only, where the sets satisfied with the properties. So, this is natural number system. This is whole numbers. This is rational numbers. This is real numbers. Union of rationals and irrationals. This is complex numbers given by this is the whole number system, which we got the idea already. So, if I take plus, the first two properties are satisfied on n. Because if you take any two natural numbers, again you will get a natural number on adding. So, closure law will be satisfied. If you take any three numbers, you can add them in any manner, they are equal. So, you will get associative law. So, identity is not there in natural numbers, because if I take a number, on adding what value I should get A again. Actually it is 0. Since 0 is not there, so n has only two properties, closure and associative. Clear? Are you getting the concept or not? Right. Now, coming for whole numbers, it has closure law, associative law, and identity also, because 0 is presented here. So, it has two properties. It contains three properties. So, if you talk of inverse, that means if I take a number A in W, on adding what value I should get 0. It is nothing but if I take 5, I should take minus 5. Is minus 5 a part of W? So, inverse property is violated in W. It contains only 3 properties among the total 4. So, since negative numbers are presented in Z also, Z has all the 4 properties. Therefore, it is a group. So that we can say Z comma plus is a group, Q comma plus is a group, R comma plus is a group, C comma plus is a group. Integers is a group with respect to operation plus. Rational numbers is a group with respect to operation plus. Similarly, real numbers, similarly complex numbers. These are groups. You can check the properties. Don't misunderstand that this is a big set, this is a big set, this is a big set, so they are getting satisfied. Not at all. I am verifying each and every property of the 4: closure, associative, identity, inverse on a set. Since they are getting satisfied, I am calling them as the groups. Okay? Are you clear? All of you. Now, let us do the case that suppose apart from taking plus, let us take the operation multiplication. So, if you take the natural number system, take any 2 numbers, you multiply them. Is it again a natural number or not? Yes. So, it satisfies the first property, closure law. You take associative law, you take any 3 numbers, you multiply them in any manner, the result is same. You can say A dot B dot C, A dot B dot C, or you can use the operation star. So you can take any 3 numbers. Yes. Here we are studying the properties one after the other. Right? First you get the concept fundamentally clear, then we do the problems. There you can understand what we are doing actually with regard to group theory. Fine. Right? There is no need to verification, because if you say real number system, you have huge number of values. How you are going to verify them? Please understand. Let me say, if I have taken a set, say G is equal to only 3 values, alpha, beta, gamma. So I can perform addition, subtraction, multiplication in all possible ways so that I can verify the 4 properties. If there is an infinite set, you need to verify for each and every element in the infinite set the 4 properties. Is it possible to verify? That's why there are certain results framed. So based on the result, if the result is satisfied by a set, immediately we say that it is a group. There is no need to verify for all the elements. That's why you keep concentrating on the context of what I am saying. Later we discuss with the approach. Because I want to give a strong fundamental thing for you. Because if you get the fundamentals clearly, the next sessions will be very interesting for you. Otherwise, you will get more boredom. So, where are we? I am talking about the associative law with regard to the number system n. I have taken the operation multiplication. Now, the question is, if I take a number a, on multiplying with what number, I will get a again. If I have taken a, on multiplying with what number, I will get a again. It is just like 1, right? 5 into 1, 5. 6 into 1, 6. Isn't it? So, is 1 belong to the n or not? Yes. So, the natural number system has 3 properties: closure, associative, identity. Please understand, earlier we have discussed that if you take plus, n has only two properties. But if you take multiplication, n has three properties. Did you observe? If you take the operation plus, n satisfies only two conditions, closure, associative. Identity is not there because 0 is not there in n. If you take the change of operation, that is multiplication, n is satisfying three properties, closure, associative, and identity. Now, let us go with the part of inverse. So, what is identity here? 1. 1 is the multiplicative identity, 0 is the additive identity. So, if I take a value a, on multiplying with what value, I should get 1. In this place, what I have to take to get 1? 1 by 8. That means if I take 2, on multiplying with 1 by 2, I will get 1. So, E is 1 by 2 belongs to n. E is 1 by 2 belongs to W. So, the fourth property, inverse, is not satisfied by n and w and z also, because fractions are not there. So from q onwards you will get the fractions. So we can say that q comma dot is a group, I mean multiplication. R comma dot is a group. C comma dot is a group. Now see the difference. Earlier, if I take the operation plus, groups are started from Z onwards, Z, Q, R, C. But if I take the operation dot, that is multiplication, groups are started from Q onwards, Z is not there. Did you understand? Now, if you consolidate our whole perspective, it is nothing but whenever you have a set available with you, you have an operation given, then with regard to the operation, the set may satisfy all the four properties or some of them. If a set satisfies all the four properties, then we call that it is a group. Otherwise, we simply say that it is not a group. Please understand that we have discussed the case with the number system. This concept is applicable to all kinds of sets. You can take matrices, you can take polynomials, you can take functions, you can take regular numbers, you can take a separate set, or you can take a sequence of numbers. So, the set elements may be of any kind. So, the elements you are talking or discussing or dealing with are of any kind. You can take numbers, polynomials, functions, permutations, anything. But you are simply verifying that I have given a set, I got an operation. Is this operation on the set satisfying the four properties or not? If it satisfies, it is a group, otherwise not a group. That's all. Clear now? So, please understand that we are calling it as an abstract algebra. Why we are calling it as an abstract? Whenever a system is available with you, you are applying a theory, closure, associative, identity, inverse. So you are applying the theory on this system. So if the system accepts this theory, it is a group, otherwise not. So whenever you have a physical or real life application, if you want to apply group theory on that, you should ensure that the system you have taken satisfies the properties of group. You can have an operation on it so that you can mold that system so that it is a group. Let me say, everyone has seen Rubik's Cube. Have you seen Rubik's Cube? Right? So, Rubik's Cube is a group. Here, the operation is nothing but rotation. So how do you verify? If you take Rubik's cube, you can rotate that. You can rotate this horizontally, vertically, or any other way possible. Front part, middle part, end part, or top or down. So what happens? If you perform one rotation, you are going to get the same colors of the cube. You are not getting any different color, isn't it? So closure law is just like that. If you talk of associative law, see A, B, C. So you are doing the rotations. Let me say I have rotated the first part. Then I rotated the top. Then I rotated the bottom. You can do the thing anyway. So first rotate top, then bottom, then side. You check that the previous phase and the current phase are same or not. So you perform LHS and RHS. Are they giving the same phase or not? So associative law is satisfied. So like that we verify. So please understand that the system what you have taken, you should get an operation. The operation may be of any kind. So if you take only matrices, plus means matrix addition. So with regard to matrix addition, I am verifying the properties. So I have taken all the 2 by 2 matrices in a system. So what is meant by closure law? If I take two 2 by 2 matrices, if I add them, is it a 2 by 2 matrix or not? So what is associative law? I have taken three 2 by 2 matrices, A, B, C. You can add them in any manner, A plus B plus C, or A plus B plus C. Whatever they do, the resultant 2 by 2 matrix must be same. And what is identity? The 0, 0 matrix. If you take any 2 by 2 matrix, if you add with 0 matrix, you will get again the same matrix. And what is inverse? You know how to calculate the inverse of a matrix? So the inverse you obtained must belong to the same set. Then inverse is verified. So if you talk of functions, you have composition of functions F circle G. So F circle G using the operation, you should verify closure, associative, identity, inverse. If the set of functions taken by you in a set satisfies these four properties, we say that it is a group, otherwise not a group. Okay? This is the whole phenomena. Since this is the orientation class, I want to stop here. If you are interested, I will continue. Based on your input, I will go. What do you say? Fine. So if you prove any theorem, any result in group theory, it is applicable to every set, wherever it is a group. That's it. So don't be scared of group theory. Let us do a small problem which gives the interesting thing for you. So please take a note of the problem. We discuss with the solution. After noting, please tell. So I have taken the set of only positive rational numbers. So I am not taking the negative, I am not taking the zero. I am taking only positive rational numbers. And on this set, I took the operation circle. Please understand, operation here means not only addition multiplication, you can take any kind of operation as per your convenience. And how the operation is defined, if you take any two values, the operation is circle defined that first you multiply them and divide with 3. So if I say 5 circle 7, it means that 5 into 7 by 3. This is my operation, nothing but 35 by 3. Are you getting the result? How the operation is defined? So the question is this operation satisfies the properties of group or not? In the question, it is given that abelian group. I will tell you what is meant by abelian later. So I have to verify the 4 properties: closure, associative, identity, inverse on the set Q plus with regard to this operation. The first part is here closure law is satisfied trivially because you take two values in Q plus. It means are they positive or not? Yes, are they positive or not? Right. So if you perform the operation, is it positive or something different? Just we did the thing. If I perform the operation, the result, is it positive or something different? Positive. It is a positive rational number. Accepted. So A circle B is equal to AB by 3. It belongs to Q plus. So how we are verifying closure law here? Closure law is nothing but if you have taken two elements in a set, if you perform the operation, the result must belong to the same set. It means that the result must be in the same pattern of the set defined. So how the set defined? The set is nothing but positive rational numbers. So if you perform the operation, the result must be again a positive rational number. If it is so, then we say that closure law is satisfied. Okay. Now let us go with associative law. Let us take three elements. A, B, C belongs to Q plus. I need to calculate the LHS, RHS separately. So if I do A circle, B circle, C, what happens? So it is A circle, B circle, C means as per the condition defined BC by 3. Again, how the condition is defined? Whenever you take two values, you multiply them and divide with 3. So if you perform the thing, it is nothing but ABC by 3. Sorry, by 9. Accepted? The result. Now you go for RHS. If I do A circle B circle C, from this definition it is AB by 3 circle C. Again applying the operation, I will get ABC by 9. Now you can check that this value both are equal. So it is nothing but A circle B circle C is equal to A circle B circle C. So associative law is satisfied. You please take a note of that. Then I discuss the other parts. After noting, you please tell. Please understand, this group theory will not contain any formal writing in the paper representation. Here, if you are able to present the idea in your own words, you will be given full marks. But if you talk of any chapter, there is a formal writing. Formula, substitution, conclusion, evaluation, everything is formal writing. Here, there is no need of formal writing. You just need to present the concept and definition so that you are conferring the result. That's it. Okay. Now, I want to verify identity. So, what is meant by identity here? Let me say, if I take a value in Q plus, I need to check if there is some value in Q plus such that the result is again A. This is identity. Can I find any element in Q plus such that after performing the operation, I should get the same element again? Clear. So let us verify for this. Let us say E. Let A circle E is equal to A. Now I have to find what is the possible value of E. So let us apply the operation here. This implies A into E by 3 is equal to A. Implies A dot E minus 3A equal to 0. So this implies A into E minus 3 is equal to 0. So from this relation you can say that since the product of two values is 0, either A must be 0 or E minus 3 must be 0. Since we have taken A belongs to Q plus, A is a positive value. So A cannot be 0. Therefore, E minus 3 equal to 0 implies E is equal to 3. So what does it mean? You take any number A in Q plus. If you take 3, if you perform the operation, you will get the same number A. For example, let me say I have taken 10. So if I perform 10 circle E, I will get 10 again. Because 10 circle E means 3. If you done, it is nothing but 10 into 3 by 3. You will get 10 again. Are you getting the logic? So 3 is nothing but identity element there. But if you talk of regular multiplication, 1 is identity element. You take any number, you multiply with 1, you will get the same number. But here, since the operation is different, identity is different here. Did you get the idea? How the identity element is defined? You take a note of that. Then we discuss about the inverse part. How do we calculate the inverse? Shall I continue? All right. So let us take A belongs to Q plus. Say B is inverse of A. So I need to check what is the B value. Since B is inverse, from definition, A circle B is equal to identity, the definition. Since I have taken that B is inverse of A circle B is equal to E. So if you apply the part, AB by 3 is equal to E means 3. Already we know what is meant by identity. We have calculated the value. So this implies AB is equal to 9, implies B is equal to 9 by A. So that is the inverse value. So what does it mean? If I take that A is equal to 5, the inverse is 9 by 5. If I take that A is equal to 100, inverse is 9 by 100. So whatever the element you take, the inverse is 9 by that number. Okay. So if you have doubt, you can check that. Let me say, I have taken A is equal to 15. Say, what will be B? B is equal to 9 by 15. Now you check the operation. A circle B, it is nothing but 15 circle 9 by 15. From the definition, 15 into 9 by 15 whole by 3. Gets cancelled, 3 you will get. It is nothing but identity. Did you observe? If you perform the operation with inverse, you should get identity at the end. Are you getting the logic? What is meant by inverse? All of you. Any questions? Right. So, I have proved closure, associative, identity, inverse. Therefore, Q plus comma circle is a group. So if anybody has any doubts, you can ask. Any doubts on this part? All right. So whenever you have a set and an operation, if you write them together putting brackets, we call it as algebraic structure or algebraic system. If I say z comma plus, z is a set, plus is the operation, I say that z comma plus is an algebraic structure. Okay? Are you clear with it? Now, Q plus comma circle is a group we have proved. There is one more word, abelian group. What is meant by abelian group? After checking 4 properties, we will check one more property, that is 5th property. We call it as abelian property or commutative property. It is nothing but you have to verify A circle B is equal to B circle A. Just like 3 into 5 is equal to 5 into 3. Are they equal or not? Then we say that it is commutative. Please understand, if a set is group, it need not be commutative always. Because, let me say, if I have taken all 2 by 2 matrices in a set, let me say, I have taken A 2 by 2 matrix, I have taken B, a 2 by 2 matrix. Can you say that always AB is equal to BA? Can you say that always AB is equal to BA possible in 2 by 2 matrices? I will take one more example. Suppose you take all functions. I have taken 2 functions f, g. Is f circle g is equal to g circle f? You have calculated functions at the school level, 8th class, 9th class level, I hope. Is f circle g is equal to g circle f always? Sometimes it may be equal, sometimes it not, right? So, please understand that every group need not be abelian. There are variations. So, the 5th property is AB is equal to BA. If you take plus, A plus B is equal to B plus A. If you take dot, A dot B is equal to B dot A. This 5th property is called abelian property or commutative property. Here, you can verify that A circle B is equal to B circle A because AB by 3 is equal to BA by 3. Both are equal. So, given group is abelian also, it is an abelian group. So, in this way, whenever a set, an operation is given to us, we are going to verify whether it is a group or not. Clear? Now, let us stop our session here. Tomorrow we will meet more problems. Tomorrow is Friday, so we are taking class also. We don't want to take a break for abstract algebra right now. So tomorrow we will take a class on this part. So let us do more number of problems. When a set and operation is given to you, how we are verifying the group. Is it a group or not? How we are calculating, we will do. So that you will get interested. Now, as per the class discussion is concerned, do you have any queries? And if you want to give some feedback, you can give. At what areas we need to elaborate our discussion. You can give up. Please tell. Anything you want to share. Any queries, doubts, your feedback, anything, etc. Exam hall, we can take scientific calculator with us. It is 991 MS. We can bring scientific calculator to the exam hall. It is allowed. Any other doubts, please, to anyone? So with regard to Indian civils, the freshers who are appearing for the first time here, so as in when you join in our course, we will take 1 year duration, right, from the time of your joining. So within 1 year duration, we will complete the whole syllabus. So at the end, we will conduct a test series for you. So for the overview, it contains chapter-wise tests as well as grand tests patterned in the UPSC model, paper 1 as well as paper 2. So around we will conduct 25 tests, topic as well as grand tests. So after conducting the tests, we will evaluate the test and we will give marks to you also. So based on the assessment, you can check your preparation, how far you can compete with the level of UPSC, and you can assess yourself. That is our overall view with regard to your contribution. And we have the material also. Whoever will pay the fee, they will get the material. It will be sent to post. So you can get the material which gives a basic level of understanding up to certain level for your preparation. Apart from bulky material having, you can have a concise material. So once you pay the fee, you will get the study material. It will be sent to you through post. Right? So thanks to everyone. That's all for today. We will meet tomorrow. And thanks for your good listening.